So let us take a couple of examples for doing Carnot map minimization. So let us take our first example. Now let us say f is represented using a sum of mean term 1, 3 and 7. So because it has going to be like we say that this is this will have these three variables, and let us try to follow one terminology that the variable which is written at first place is the most significant variable, and the variable which is written in the end is the least significant variable. So that would help us in having one-to-one correspondence with these mean terms. So how to create a K-map for this? We generally write A here, we write B and C, and there has to be these 8 cells. So this cell we can say represent 0, this cell represent 1, this is 0 0 0 1 1 1 and 1 0. So because mean term 1 would mean that 0 0, so this has to be 0 0 1, so that means this has to be 1. Now for mean term 3, A has to be 0 and B and C both are 1, so we can write 1 here. And for mean term 7, we can say A, B, C. A is 1, B and C both are 1. Now this is how we will fill this mean term table and this K map. Now we can find out what are the adjacent terms which can be minimized. So you can see this one and this one form adjacent terms. This is called 1 cube. So similarly, this one and this one can be also combined and form another cube. This one and this one cannot be combined because they are diagonal, they are not adjacent. So each of the combined group, we can then say that what would be the minimized expression. So for example, for this one, the minimized expression would be 1 1, because this 0 and 1 will get minimized. So this I can write as B and C. Similarly, this one, the thing which is 0 and 1 will get minimized. So otherwise 0 is same for both of it, and C equal to 1 is also same. So B will get minimized. So I can write this as A dash and C. The whole function f can be written as A dash C plus B C. So this is how we can come up with a minimized expression. So similar to this, you can also let's do it for the max term expression. Let us say the same function f can be written as also be written as the max term. So let's say for max term I'll use this blue color. So this violet color. So this f can be written as, so this is product of m 0 2 4 5 and 6. So again I'll draw this table or a K map. So in the similar way, there would be A here, this is B and C, this is 0, this is 0, this is 0 0 0 1 1 1 1 0. So the another way which help us sometime is we write in one corner that this is 0, this is 1, this is 2, this is 3, this is 4, 5, 6 and 7. Now for this term these are the zeros, so I'll put them in, let's say, in the black so that it is more visible. We'll make it in the black. So this is 0, and 2 is, and 4, 5 and 6. So what all can be combined? So here the combination, because these two can be combined, and further these two and these two, they also form, they form a square, so we can combine them and these two. So essentially these, sometimes we also write these groups. So this can be, there are 4 groups. One is 0, 4, 6 and 7. This is one group. The other group is 4 and 5. So corresponding to this group, what would be the term? The term would be, because this was 0, this is 1, yeah, so this was 1, so 0 and 1, this, that means a term will not be there. Similarly B is 0 and 1 here, so B will not be here, so only C would be there. So corresponding to this, the term would be, and C is 0, so it has to be C. And for 4 and 5, this will become, so this is 1, so that means it has to be A dash, and for there will not be C term because C is 0 and 1 here, so C, because of this pair, C will go away, so this is B plus A dash. So I can write the whole expression also as product C A dash plus B. So if you see that this expression and this expression are actually equivalent. So this is how we can create using a sum of product or using product of sum. So let us try out one more example. Let us say our we wanted to minimize, let us say we wanted to minimize something with 4 variables. So with 4 variables, and let us say it also have these don't care conditions. So we use something which will have don't care conditions also. Let us say this f is sum of mean terms 1, 3, 5, 7 and 9, and let us say it also has some of the don't care conditions which are 6, 12 and 13. So we'll try to do it without don't care conditions, and we'll also do it with don't care conditions. So first of all, let us quickly draw our K map. So while drawing the K map, because it is of 4 variables, so we will create 16 cells, and let us say A and B are here and C and D is here. So this function is of, let's say, A, B, C, D. So that means A form the highest significant bit and D form the least significant bit. So we write the gray code here like 0 0 0 1 1 1 1 0. Here also we write 0 0 0 1 1 1 1 0, and in the corner of each cell we write their corresponding mean term so that it's easy for us to remember. So let us say we are writing it 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. So after writing the mean terms and creating this map, then we will fill up the terms. So this term is 1, 3 is 1, 5 is 1, 7 is 1 and 9 is 1. So don't care conditions, instead of writing 1 and 0, we represent them using x. So 6 is x, and 12 and 13 are also x. Where is 13? 13 is here and 12 is here. So now I wanted to create cubes, or I wanted to combine the terms. So we will see that we can see a combination here which can form a cube. So like these two, 1 and 3 were adjacent, 5 and 7 were adjacent, 1 3 and 5 7 were adjacent, so we created a bigger cube. The other possibility was that we could have done this and this. So we can make a group of 1 and 9. So corresponding to 1 and 9, the variable would have been, so the mean product term would have been. So we see what changes, what doesn't changes. Here 0 and 1 does not change for this row, so we can directly write C dash D. And for this term and this term, A is 0 and 1, so A can be minimized, but B is same for both of these mean terms, so we can write B here. B is would be there in the complemented form, so this is B dash. Okay, so what about this? For this, you see that C would be optimized because C is 0 here and 1 here, but D is constant, so D will remain. And similarly we see on the top, so we see that B would be optimized because B is 0 here and 1 here, but A is constant for both of them, so we can write A in the complemented form. So if I don't consider don't cares, my function f would be written as A dash D plus B dash C dash D. So this is how we can optimize. Now let us say these don't care conditions are also given. So don't care conditions means these input combinations will never come or will not be possible. So because these combinations will not be possible, so what we can do is we can if those conditions are in a favorable cases, so in those favorable cases we can combine them to create something which would be of minimum form. So for example, here this particular x, this 13, can help me in creating a cube which is bigger. So I can go ahead and create this cube. Okay, so this cube will have less number of literals and this cube would be only C dash D. So if I am including these don't care terms, then my expression f can be written as A dash D plus and C dash D. So this function can be represented, which is this function f is a more optimized function because it has less number of literals, although number of terms are same, but literals in this case is lesser. So this forms the more optimized version. So this is how we can solve the K maps for 4 variables. So let us do one more thing here. So we have some 5 more minutes, so let's try to clear. Yeah, so let us say we now there is some expression which is available to us in not in form of mean terms but in form of a unoptimized expression, and we wanted to optimize this expression. So let us say the function is given as function is of a comma b comma c and is equal to a b c dash plus b dash c plus a dash. Now we would like to optimize such kind of a function. So if we have to optimize a function which is given to us, now how we can do it is we can also create a K map corresponding to this. Now you see that mean terms are not given. So even though mean terms are not given, so we can still create a K map which could be helpful here. Here, that's why we are not writing in the in small 0 1 2 3 4 5 6, but we can directly write from here. So this a b c dash will be a is 1, b is 1, and c is 0. So that means this is this particular mean term. So this is a is 1, b is 1, and c is 0. So here this is b dash c. B dash b is 0 and c is 1, but there is no a, so that means it has to be this as well as this. Now let us see a dash. A dash means this is 1, this is 1, this is 1. Now if I want to group and combine, so I can see that this a dash is anyway there. Now I can also combine these two, I can also combine these two. So this is a dash, we know, and this will become b dash c, and this will become b c dash. So the whole expression, then this f can also be written as a dash plus b dash c plus b c dash. So similarly we can take more examples. So maybe I'll share a couple of tutorial questions to you, and then you can solve those questions and we can discuss them in tutorial. Thank you very much.